All right, hello. Let's do some calculus problems. So the lectures for today were about finding the area between curves. Um, so let's go ahead and do that. We're going to start with some easy examples, and we'll ramp up to things that are a little more interesting. All right. So let's start over here with problem 1. All right. So we have the equations y equals 2x, y equals 1/2 x, and x equals 2. Right. I want to find the area bounded by these. So let's go ahead and draw a graph. So 1, 2, 1, 2. Actually, I probably need some more room than that. So let's do this. 1, 2, 3, 4. 2 is going to be about here. 1 would then be about here. Right. So let's draw a graph. I'm going to do this one in blue. My hotkey for muting the mic and putting the camera on are right next to each other, so enjoy me sneezing, apparently. Also, why is my camera off, though? Right, anyway, so we're going to do this one in blue, this one in green, and this one in not also green, but red. Alright. So, actually, we'll do this one first. X equals 2 is pretty easy. It's just this our vertical line, I mean. Y equals 2x is this here. And y equals 1/2 x would be this line. Okay. So the region that they all bound is this area right here. We want to find that area. So what we need to do is do an integral here of the top minus the bottom. Because if we do that, we're essentially saying take the area under the blue one and subtract the area under the green one. Right, so here, these both cross at the origin, and this is stopping at x equals 2. So the area, in fact, maybe I'll just do it over here. The area of this is going to be the integral from 0 to 2 of the top function, 2x, minus the bottom function, 1/2 x, dx. So we're really doing the integral from 0 to 2 of 3/2 x dx. And so when we integrate this, we're going to get 3 over 4 x squared from 0 to 2, which is actually exactly 3. Interesting. All right. Here we go. All right, so let's go ahead and do the next problem. All right, problem 2 here. We have two curves, y equals x and y equals x squared minus 2. And I want to find the area between these two. Okay. So let's go ahead and graph these. Again, I'm going to do first one in blue, second one in green. All right, let's see here. Let's draw my axes like this. 1, 2, 1, 2, 2, 1, 2. All right, so the blue curve is our usual diagonal line. No big deal at all. Here, this is a parabola. The standard parabola shifted down 2 units. So that'll look something like this. Close enough. All right, so we're finding the area in here. I hope we didn't do exactly this problem in in the lectures. I actually can't remember now. But anyway, we want to do top minus bottom when we're doing this integral again. But we need to find the bounds. And to find the bounds, we just set the two functions equal to each other. So x equals x squared minus 2. Move this to the right. 0 is x squared minus x minus 2. All right, factor this. This is x minus 2, x plus 1. And so we have x is 2 and negative 1. So those are our bounds for this integral, because that's going to tell us where these functions cross at. So we just need to do the integral now. So the area is going to be the integral from minus 1 to 2 of the top function, which is x, minus the bottom function. Okay. So let's go ahead and simplify this on the inside here. And then integrate it. Oops, I said integrate it. 1/2 x squared minus 1/3 x cubed plus 2x. All right, we integrate this from minus 1 to 2. So go ahead and plug this stuff in. This is going to be 2 minus 8/3 plus 4 minus 1/2 plus 1/3 minus 2. All right, so what are we going to get here? This is going to be a number. So this will be 6 minus 8/3 minus 1/2 minus 1/3 plus 2. So let's see. This is 8 minus 3, so that's 5 minus 1/2. So this is 9/2. I think we just had a very similar one in the lectures. Or maybe this is the same one. I can't remember, honestly. But yeah. I accidentally picked the same problem. Right. Any questions here at all? Awesome. Go ahead and go on to the next one then. Right. Problem 3. Right. Here we want to find the area bounded by y equals minus x squared plus 4 x and y equals x squared minus 2x. So the reason I picked this problem here is, we could sort of figure this out by hand. It won't be honestly that bad to do at all. But let's go ahead and look at this one in Mathematica. Right. So we want to plot our two functions here. We have minus x squared plus 4x and x squared minus 2x. Right. And let's take a guess and say x goes from minus 2 to 2. Probably have to expand that, but let's just take a stab at it here. All right, so we have a crossing here at 0 and something probably further out here. So let's change this to -1 and 4, maybe. Okay, great. So we have this here. So it looks like they're crossing at 0 and 3. Probably not that hard to ensure that's true. But here's something else we can do. Right? We have these two functions that we want to essentially set equal to each other here and solve for x. So remember, we have the solve command in Mathematica. So we can take the two expressions, set them equal to each other, and solve that for x. Right? And look at that, 0 and 3, just like the graph suggested. Right, so we can use Mathematica as well to solve for x. You know, in this situation, it's not really that necessary. We can solve these pretty easily by hand. But if we had more complicated functions, it might be extremely worthwhile to use Mathematica. All right, but now the benefit is that we can just get right to the integration, and we can compute that right here in Mathematica as well. Because again, setting up the integral is more interesting than actually computing it at this point. So, integrate. Right, we want to do the top function minus the bottom. So let's see. The top function is the blue one, which is this first one I have here. And then we want to subtract the bottom one, which is x squared minus 2x. Right, so we're integrating the top minus the bottom here. This isn't strictly necessary, but I'll put parentheses around this just to emphasize. Top minus bottom here. Right, and here x goes from 0 to 3. Right? Sorry, let me just write something here. PDF. Right. So we just integrate this, and bam, there we go. 9. So it does that for us pretty quickly. Right. So, you know, that integral, that area integral was from 0 to 3 of x squared minus 2x minus negative x squared plus 4x. And Mathematica tells us that this is 9. So again, at this point, computing this integral is not super exciting. All right. So let's look at another interesting question here. Problem 4. And we're saying, let's find the area bounded by y equals sine of x and y equals negative cosine of x. Right, so we want to compute this area. Okay, so again, let's pop over to Mathematica and see what's going on here. Right, sorry, find the area. I left out some words of one region. Right, we want one region bounded by these two functions here. So what do I mean by that? So let's pop over to Mathematica again. And let's plot. Let's see, here we have sine of x and minus cosine of x. And here, let's say x goes from minus pi to pi. That seems like a pretty good range for sine and cosine. So if we plot this, we can see a region here bounded by these two curves. Now, why do I specify one region? Well, if we expand this, you can see there's multiple regions bounded by these two functions, right? And in fact, there's infinitely many. So this is why you have to specify one region. And the interesting thing is all of these regions between the two functions have the same area, right? This is just a mirror image of this. This is the same as this over here. This will be the same as this one. So, sorry, I always forget. It captures my cursor in wrong places. Yeah, so this is a mirror image of this. This and this are the same. This and this are the same. Right? So we only want to focus on just this one area here. Right? So we can even say, all right, well, let's focus from like -2 to, I don't know, 3. Right, so I just want this one area here. So when do these cross? Well, why not look at our solve command? All right. So if we look at this, what do we have? All right, we have this sort of weird expression here, right? So we have this like 2 pi c1 stuff going on. What that means is, so here, negative pi over 4 is somewhere that they cross, right here, negative pi over 4. And then the plus 2 pi c, remember, you know, that means it's going to happen again in the next period. So just going back to expand the graph here, you know, that's saying, okay, here's negative pi over 4. Here's negative pi over 4 plus 2 pi. Okay? And then for the other one, okay, here's 3 pi over 4. The next one would be 3 pi over 4 plus 2 pi. But we can also use negative numbers for C1 and say 3 pi over 4 minus 2 pi. So that puts us at this one here. Right? So there's infinitely many of those crossings, and that's what this 2 pi C1 stuff is all about. Right? But what we do see here is, well, this is negative pi over 4. This is 3 pi over 4. So there's our interval of integration. So the area will be integrate of, let's see, the top function is going to be sine of x. The bottom function will be negative cosine of x. Right, and we want to integrate from minus pi over 4 to 3 pi over 4. All right, how's that look? Right, so integrate that, and we get 2 square root of 2. So that's the area of one of these little regions here. So let's go back over to the tablet. So we found that the area is the integral from minus pi over 4 to 3 pi. Oops, that's not a pi, is it? 3 pi on 4 of sine of x minus negative cosine of x. And we found out that's 2 square root of 2. I don't know why I wrote square root of x. All right. Any question there at all? So again, you know, Mathematica is a great help for these kind of geometric problems to sort of sort out what's going on. And then, you know, once you know how to set up the integral, you may as well just do it in Mathematica. Okay. So let's look at problem 5. Right. So here we're looking at y equals x and y equals x cubed. We want to find the area bounded by these. Right? So this is another thing we could use Mathematica for, but let's do this one by hand. Right? We've done enough Mathematica for a moment. So I'm going to graph this one in blue, this one in green. Let's see, let's put 1, 1, 1. These are 1. Right, so what does this graph look like? Something like this. We got that line here, y equals x. And then x cubed is something that's pretty flat and then shoots up. And it's pretty flat and then shoots. Right, so we're really looking at, that's not quite what I want to do. So we're looking for the area in both of these little leaves here. Okay. So to compute that area, notice that on this side, the green function's on top, x cubed is on top, and on this side, x is on top. So we just have to split this into two separate pieces. All right, so A, the area. Oh, sorry, we first need to find where these intersect at. Right, so this probably isn't too difficult to do, but let's go ahead and do it. So x, I'm going to write them in this way. X cubed equals x. So x cubed minus x, which we can factor as x times x squared minus 1, which can factor as x plus 1, x minus 1 equals 0. So here we go. We see x is 0, minus 1, and 1. Right? So that corresponds to these three intersections here. All right, so now we just set up the integral for the area. Integral from minus 1 to 0. This is going to be x cubed minus x, because again, we want to subtract the top from the bottom. Right? Dx. Right? And then plus the integral from 0 to 1 of, again, top minus bottom. So x minus x cubed. All right, so let's go ahead and compute these. So we're going to get 1/4 x to the 4th minus 1/2 x squared from -1 to 0 plus 1/2 x squared minus 1/4 x to the 4th from 0 to 1. So plug in all this stuff. You're going to get 0 minus 1/4 minus 1/2 plus 1/2 minus 1/4 minus 0. All right. So this is going to end us up with 3/2. Hey. Is that right? Let me make sure I got that right. No, 1/2. 1/2. All right. So that's the area between these two simple functions here. Right. Any questions there? All right, let's go ahead and do the last problem. Bit of a short one today, I suppose. But it's just area between curves. There's nothing super fancy going on here. So this one, problem 6, we got we want to graph find the area of the region bounded by x equals square root of y equals 4x, and y equals 4. Right? So what does this region look like? Well, let's do our usual color system here. Right, blue, green, red. For this blue one, if you don't know what this graph looks like, square both sides, and you get x squared equals y. And know here that since x is equal to the square root of y, we just can't have negative x values. So what's going to happen is really we're going to be forced into the first quadrant again. 2, 3, 4. Okay, so let's graph everything we have here. So y equals 4, super easy. It's just a horizontal line. Right? Y equals 4x. We get 1 here. And we go over 1, up 4. There. So there's that one. And y equals square root of x, or sorry, x equals square root of y. We'll start here. When y is 1, x is 1. When y is 2, when y is 4, oh, sorry, I'm I'm looking at like the wrong axes. When y is 4, x is 2. Here. Right. So what are we looking at? We're looking at the area in here. Okay. So something interesting going on here. This one doesn't lend itself very well. We could, but it doesn't lend itself very well to doing integrals in the x direction here. And that's because, well, we'd have to sort of split it here because the top is green, the bottom is blue here, but over here the top is red and the bottom is blue. So we could very well do this as an integral with respect to x, but we'd have to split it into two pieces. On the other hand, if we look at this in the y direction, where we do left minus right, the left side is always the blue. The right side is always the blue. The left side is always the green. Right? So if we set up our area that way, with respect to y, we're going to integrate from 0 to 4, so from the bottom to the top, of the right function, which is square root of y, minus the left function. So we solve for x here, and we get 1/4 y dy. Right? So at this point, we just compute this, right? No big deal. So compute this integral. It's going to be 2/3 y to the 3/2 minus 1/8 y squared from 0 to 4. All right, so let's go ahead and do this. 4 to the 3/2 power is 8. So this is 16/3. Plug it in here. This is going to be 16/8, so minus 2. And then when we plug in 0, it's going to be 0 on both counts here. So we'll just say minus 0. So here, 16/3 minus 2 is 10/3. And that's that. Right. It's been a long day. All right. So hopefully this stuff feels pretty straightforward. I don't see anyone here in the Google Meet, but yeah. Hopefully this helps you get through the lectures and the homework and that. Yeah, I think that's it for today. Nothing too major going on. Oh, watching from the National Lab. All right, awesome. I didn't even see these comments over here. No one ever types over there, so I didn't even notice them. All right. Well, anyway, that's it for today. Take care, and see you next time.